1, 2, 3, 4, 5, 6. Solid has 6 letters. It's the lesser amount. 1, 2, 3, 4, 5, 6, 7. Solid has 7 letters. It's the greater amount. Solution has 8. It's the two of them together. Easiest way to remember the word. Soda pop. Soda pop. That's the solution. What's the solvent in soda pop? Water. What are the solutes? Not just carbon, but carbon what? Carbon dioxide. That's what gives it its fizz. Okay? What else? Come on, what else is in soda pop? Carbonation, sugar, that's why the dentists don't want to drink all the time, right? Caffeine, flavorings, color. Can you ever have more than one solvent? No, because there can only be one thing that's the most abundant. Can you have more than one solid? Yes. Absolutely. Okay? Air. Air is a solution. What's the solvent in air? Nitrogen. Nitrogen's about 80%. What are the solutes? Oxygen. Carbon dioxide, that's what we breathe out. And days like this when it's real sticky, water vapor. Okay? There's a lot of water vapor, more water vapor today. That's what feels so sticky than there is on days when it's not that much. Okay? So solution. Okay. If it's not uniform, then it's a heterogeneous mixture. That's you people over there. You're the heterogeneous mixture. At least we think so in this one. So, I just replaced solution here. Heterogeneous mixtures can be colloids or suspensions. Some of you probably know if you're in the right place or not based on how you come. Maybe not. Okay, the solution. Let's go on. Solutions. We already talked about Kool-Aid and air, right? We talked about soda pop. There are 9 different possibilities. In soda pop alone, we have sugar dissolved in water, a solid in water, a solid in a liquid. We have flavoring in there, probably a liquid in the liquid. We have carbon dioxide in the pop, gas in a liquid. We can do all 9 combinations. Gas and gas, gas and solid, gas and liquid. Liquid and liquid, liquid and solid, liquid and gas. Solid and solid, solid and liquid, solid and gas. Those are the 9 different possibilities for solutions. Stainless steel is an example of a solid dissolved in a solid. They heat it up and then they break it down. Colloids, the 2 most common ones are blood and milk. Now a couple of you have a pretty good idea of where you should belong now. Okay. Suspensions, orange juice. What's suspended in orange juice? Pulp if it's fresh squeezed, right? Chocolate chip cookie, what's suspended in chocolate chip cookie? Chocolate chip, I'd rather have an oat and raisin cookie myself. Muddy water? Mud in the dirt or the silt. Okay? It's also suspended on days when we get so much rain it floods, a lot of silt suspended in the flood water isn't. How do we get to here? Okay. These numbers have to do with the size of particles in the 3 different types. If it's less than a nanometer, it's going to be a solution. What's a nanometer? Well, look at the end of your pen. pen or a pencil. That's a millimeter. Chop that up 100,000 times, you get a nanometer. So it's not unbeknownst to us that I'm probably not going to see those particles in them. Okay? Because they're so small. Colloidal particles are a little bigger. What are the colloidal particles in blood? Red cells, white cells, platelets. Okay? Those are all examples of particles that would be colloidal particles. What about milk? What's the colloidal particle in milk? Whole milk.
Fat.
The cream. The cream, which kind of ties in. Okay? So they're 1 to 100. Suspension particles are greater than 100. Sometimes so big we can't see them very readily, like the chocolate chips. So, size of the particle helps us make differences between them. This next one has to do with light. Light will pass through solutions. The air is a solution. I can look out the highway and see the cars because light passes through the solution. Anybody ever fish in Canada? They tell me when you go to Canada that you can see 10, 15 feet deep into the lakes because there's no suspended particles in there. There are no colloidal particles. It's such pure water that it's just a solution. You can, there's oxygen and things dissolved in it, but it's a solution, so you can see really far into it. Go to Dubuque, the Mississippi River. Put your hand 5, 6 inches below the surface. What happens? You can't see it anymore. How come? Because there's a tremendous number of suspended particles and colloidal particles in that Mississippi water by the time it gets to the beach. It's not a solution anymore. It's colloidal and suspended. So light will pass through solutions. It will not pass through colloids or suspensions. It will scatter. Can you see through a jug of milk? What happens on foggy days? Can you see through the air on foggy days? No, so it must not be a solution anymore. What is it? Well, on foggy days, there's so much water in the air that instead of staying as gas that we can see through, it forms little droplets of water that are suspended in the air. And when the light hits those particles, what's it do? Scatters. So I can't even see the trucks on the highway on a foggy day because the light gets scattered before it bounces off the truck or car and gets back to my eye. When you drive at night, what kind of lights do you use in the fog? Dim or the low beams, right? Because they shoot, or fog lights, they shoot down close to the road. Okay, and you can see the white line or the yellow line in the middle, whatever you have to find. If you put your brights on, they shine up into the fog, and what happens? Light scatters all over the place and you can't see it. So that's another way we can differentiate between colloidal, suspension, and solution. Last one we need to look at is how do we separate them? Suspensions we can filter. So if you want to get the pulp out of the orange juice, you can either put it through some cheesecloth or some paper, and it'll take the pulp out and you'll have a solution of orange juice left then. Okay. Might be some colloidal particles in there yet. Coffee. We run it through the coffee filter, right? Where do all the grains stay, the suspended particles? Up in the top part. What runs through? The water, the liquid that absorbed or dissolved the particles from the coffee to give it its flavor and everything else. So we can filter suspensions. They will also settle out. What happens on flood days? Flood waters come out over the field grass area. When Dyersville had their big flood the last time, it spread all over those fields by Candy Cane, down that area. When the water went away, what was left? Mud. What did the suspended particles do? They settled out into the grass when the water slowed down and made a mess. They're suspended. If there were solution particles, they wouldn't settle up. Colloids, blood and milk, you have to spin. We use a thing called a centrifuge. There's one back there on the table. It spins it around really fast. Does anybody know anyone that works at UCL, United Clinical Labs? Okay, they do all the blood work for all the hospitals and doctors in Dubuque County, for that matter. If they take some of your blood, and they're going to test it for something, they send it to UCL, United Clinical Labs. If they want to test the plasma part of your blood, they will put it in a centrifuge and spin it around. All the corpuscles and the platelets and the heavy parts of the blood will go to the bottom of the test tube. At the top will be the plasma. They can then extract the plasma and do various chemical tests on it to determine what your problem might be, or if it's somebody they pulled over on the highway and they think they might be intoxicated, they'll test that to see how much alcohol is in their blood. Okay? Then they can determine, they'll charge them. But they spin it to separate the plasma from the other blood. Anybody milk? Any dairy people in here? Well, when people milk cows and they send the milk to the tank where they come to pick it up at, it must go through a filter. When it goes through that filter, does it separate the cream and the milk off from one another? No, it goes right through. What the filter does is catch any suspended particles. Filters will not separate colloids. That's why we have to spin the blood. Years ago, my grandpa and my uncle used to milk cows. And back in those days, we didn't have the pipelines and everything. So you milk the cow. We had automatic milkers, but you put it on the cow and it milked it. Then you took it off. You had to take it over and dump it in this big 10-gallon can, 10-gallon can. There was a bowl on top. It had a filter in it that caught all the flies and anything that might have gotten in it. And we took the can up to the separator shed. We poured it in the top of this machine that had a bowl on it about like this. Milk went down through the separator. There were some cones down there that spun around really fast. They would throw the heavy milk to the outside. It would be caught in one container. The lighter cream would go down the center, get caught in another container, and go over here. We then put the cream in a cooler, keep it there until they came to pick it up. Every town had their own little creamery back then. They made their own butter and then sold it to the people of the town. The butter that my grandpa and uncle had always went to the creamery network. Okay? So they made it that way. We had to separate it using those cones, spinning, centrifuging. What do you think we did with the skim milk? Skim milk was left over. We didn't sell it. You know what we did with it? Fed it to the hogs. They just loved it. Why did we feed it to the hogs? What did everybody drink back then? Whole milk. There was no market for the skim milk. Whole milk and cream was the only thing there was a market for. Okay? So we had to spin it to separate it. Lastly, solutions must be separated by distillation. Now there's a book on your desk. Open it up to page 40. You can see a distillation process. You have a sample set up to be a laboratory still. Page 40. The moonshiners, they had to separate the alcohol from their corn mash, right? So they could sell their moonshine. They did a still process, somewhat similar to this. So they'd get their corn mash, they'd throw some yeast in there and some other things, get it to ferment. The sugar from the corn would change to alcohol. It would ferment into alcohol. So now they've got this big pot full of corn and alcohol and water and the other things they'd added. All they wanted was the alcohol. So they'd start heating it. They'd heat it to about 80 degrees Celsius, because that's where alcohol boils. They'd put a cover on it. They'd catch the vapors, run a little tube over the top, As the alcohol went through the tube, it would cool down and condense. They'd catch it in their jar over here, and they could sell it. So they separated the alcohol from all the other things using distillation based on the boiling point. Alcohol boils at 80, water boils at 100. So the alcohol would evaporate and get caught. The water, if any of it did evaporate, would cool and fall back into the tub. So we separated it, separate those things using distillation. Now, what do we have up there? We've got element, compound, solution, colloid, and suspension. Where are all our elements at? On the periodic table, right? So once we get moving here, I'll tell you where to go. And then once we get moving, if you have an element, you go to the periodic table. Water is a compound, correct? Well, in this jug we have distilled water. So all the ions and everything's taken out of it so that it's pure distilled water. So when you get ready to move with your card, if you think you have a compound, you come over by the distilled water. If you think you have a colloid, colloids have to be centrifuged. See that pot sitting back there in the middle of that table? That's a centrifuge. So if you think you have a colloid, you'll go stand by the centrifuge. If you have a suspension, we will pretend that it's foggy today. And fog's a what? Suspension. So if you have a suspension, you'll go stand by the window. And lastly, right back here, see those three like candlestick holders? Those are stainless steel candlestick holders. They're a solution. So if you think you have a solution, you will go stand by the solution. So all you need is your card. Go stand by whatever you think you have. Dental, no, that's what's in your teeth. You take a shot. You take your best shot.
Stop my hair. Hey, Elsa, what is this? Is this an element? I'm going over there. Me either.
Claire's walking out of the room. She's done.
Now don't worry a whole lot about being right or wrong. Go where you think you should do. Okay? Everybody where they want to be? Okay, let's start with the elements. If you have a true element, you can find it on this. You should be able to find what's on your card. You should be able to find it on that table. What you say, Matt? Okay, but does it just say gold? Nope. You might want to try to move somewhere else. Whatever you think. Just whatever you think. So what's everybody else got? Everybody here got elements? What do you got? Bromine? Radon? Cerium? Francium? Cadmium? Palladium? Okay, so we got the elements taken care of. You the only solution? I think there should be some other people here. Let's go to compounds. Okay, everybody listen up. Compounds. What do you got? Mr. Pibb. If it's a compound, it has to be what? Distilled water should be the compound. So what do you got? Okay. What do you got? Carbon dioxide. CO2. You guys all agree carbon dioxide is compound? CO2? You want to go somewhere else?
No,
Hey!
that's what I tried.
Keep listening. Any other compounds? That's all right. Okay, let's go back here to suspension. What do we got? Deluxe pizza. Would you all agree that deluxe pizza is suspension?
I can make one of them with the pizza.
Got all kinds of stuff, doesn't it? It's all suspended. Raisin cake? What's suspended in a raisin cake? Raisins. It's one of my favorites. My grandma made the greatest raisin cake you ever tasted. It's really excellent. Sand. Sand. This is suspension too. What else we got?
Moccasins and medicine.
Good. A cup of coffee, right? A cup of coffee. So it's what's in the cup, not what's in the that's up here. What's in the cup.
Yeah.
Yellow? Hey, I'll give you a clue to suspension. Listen up. Listen up. Clue to suspension. Hey, listen. When you get your orange juice out of the refrigerator in the morning, what do you do to it before you pour it into your... Why? So the pulp gets all suspended again, right? So if you have something on your card that you would shake before you used it, where should you be? Let me say that again. Listen. If you have something on your card that you would shake before you used it, you should be at suspension. You should be back by the window. Anybody want to move? Hunter, what do you got? Can of spray paint. Suspended particles. Nah, you wouldn't shake it. Anybody else have anything they shake? Bull, what do you got?
Amoxicillin.
Do you ever remember taking amoxicillin when you were a little guy?
No.
Your hippocampus doesn't.
Hey, does anybody remember taking the pink stuff? You shake it before you use it, don't you?
So fun.
Okay? Stay with us here. Let's go over to colloids.
Oh, I'm a colloid.
Hey, come on, listen. Colloids, milk, blood. Those are easy ones, aren't they? How come butter came? What's it made of? Milk and cream, so it makes sense it would be a colloid. Anybody think of anybody else have a colloid here?
Not sure.
Gravy would be a colloid. When we heat it up, it goes colloidal and forms the thickness that we have in gravy. There's another food in this mess that's a great colloid. It wiggles and jiggles.
Jello.
Who's got Jello?
Not
You're over
Jello.
here, you're
Not
colloid.
you. I bet you threw this in there to mess with us. Because it's not anything.
You're a colloid.
It's not too dark. Okay, so we got solutions here. We got coffee.
I was right, Miles.
We got Mr. Pibb. We got vinegar.
No.
We have 14 karat gold. Yes.
Oh, I am?
Yes. 14 karat gold is silver and gold mixed together. It's a solution. Okay? Dental amalgam is mercury and silver dissolved in mercury.
So you're getting like 13 and a half carats.
It's a solution.
Like another carat of like silver.
Who's in the wrong place, Shaq?
Then you had a carat.
Alcohol.
And then a real
Who had sand?
Corey, you're in the way wrong spot. Get out of here.
Give you a clue.
think you should come out.
Corey's saying silicon dioxide, SiO2. So what is it?
That's why you got sand. Because it got so much in it.
Alcohol? C2H5O is alcohol.
R. Why is it a big R?
Get everybody in the right place?
And then that's what happens when I bring a water.
Salad dressing. When you get your salad dressing out of the refrigerator, what do you do with it? Because it's suspension. Volcanic dust after what you doing?
She's like, yeah, I'm sure you.
It's in the air, it's
I
what?
wonder why.
It'll fall back, right? So what is it?
This game on Friday.
And it's what in the air?
What is that?
Hey, I think we're gonna be in the right place. Head back to your station, your desk.
All right.
Go back to your real desk now. Got your notebook.
What did you say?
Now your new problems up here. Your new problems will relate directly to what we talked about today. Just break 20. We got about 20 minutes. Yeah, pass your cards back to the front.
Hey, Dylan, you my Pop-Tart? Dylan. What? My Pop-Tart, but I think it's fine. You told us to. No, good. Why did I? No, you too. Okay, I don't know. Darn, it was me. Yeah, it did. You told us to, I thought. I didn't actually.
Okay. You know, if you look at the first question, name 3 states of matter. First thing we talked about, right? What are they? Gas, liquid, solid. If you go through these, start working on them right now, you're going to find they're going to be pretty easy. Most of it, you'll just be able to know an answer. You won't have to look up a bunch of stuff. Maybe a few things. Get stuck on something, let me know. I'll come and help you. I'll leave this up here so you have a reference to look back. Might help you. You guys think the cards help? What did you think? Now we have to learn how to take what we've learned and apply it to other things. And you'll have to do some of that in your assignment. These will start in chapter 2, so they'll be like in the other section. Remember, these questions, they will start, like number 2 is at the end of section 1.1. Some of them are at the end of the chapter. 10 to 19 will end in section 2, I believe. They bounce around the chapter. You just got to go look for it. I'm giving you this information different than the book does. Everything will be at 2.1 and then go from there.
you doing?
Good. Where was I? Okay, I did these wrong, I think. So help me. So with these, do I just change them to slope-intercept form? No? So, that's what I did, and then I don't think they're working.
But it's -34.
Oh, yeah.
And slope of 2.
I made it way more complicated.
So you go
So-
up 3 and up 4 and then make a point and then go up to
Alright.
an over and make your other point and make the back.
Okay, I'm done on the other one. You guys teach me first, then. Like the brush is the same size as it. You could also